let everyone join. I think people take 2-3 minutes to join. So anyone, I think some people are trying to do what has been told. Like people are discussing about homeworks and all. That is good to see. But there are still very few people who are just trying. So I just want to tell everyone, please try, please utilize these 4 5 weeks you have. Otherwise, this will go like any other course or anything that you might have taken earlier, right? Until unless you do things from your side, you write code from your side, it won't help that much. We can talk for 1 or 2 minutes and people join. Hello. Anything from any feedback? Like you have done 3 classes, anything that you want to incorporate in this course?
Co-routines is one expectation from this
A
class.
lot of noise is coming from your side.
Yeah. Uh,
Can you
I,
check?
yeah, sure. Is it good now? Is it fine?
A lot of background noise. Yeah, can you
Okay.
speak now?
Yeah, co-routines is
Yeah.
one kind of expectation from this class for me.
Mm-hmm.
I'm looking for co-routines from long time, just to
Okay.
practice with the networking. Like I just want to see how it is used in the networking.
Co-routines.
Correct.
Okay. Okay. Let's see if we can incorporate co-routines also.
Thank you.
Okay. But before that, we have to be good with multi-threading. Before
Yes.
we, because once you understand multi-threading, then co-routines is easy.
Yeah. Thank you.
Okay. Uh, Also, what other things like uh, STL we have already done. So this today it will be all about multi-threading, all the concepts and all. And maybe next week we'll take one more class for the multi-threading, and after that we'll jump into the networking part. Correct? So please guys start doing all the homework. Yeah, and I was just thinking whether after or just at the end of the class, is it if I give some 2 3 something like this, these are most asked questions in CPP interviews, will it be helpful? I won't do it, but I will tell you these questions 1 or 2 at the end of every class. Then
Yeah,
then
yeah,
you can
it
do
will be
it
super
and put
helpful.
it on Discord.
Yes, Amit, Amit.
Yeah.
That will be very helpful, I think. Yeah,
Okay.
Yeah,
yeah.
that
Okay.
would be helpful. In fact, in the course only you can put a FAQ list of so even for last minute revision also it will help us if there is an interview suddenly impromptu.
हम्म ओके ओके ठीक है okay I think let's start with the discussions. I will share my screen. Okay, so let me know once you see the screen. Everything okay, 1 second. I think my mic is not properly. 1 second. Can you hear me properly?
Yeah, it is super clear now. Yeah.
Okay. So okay, you can see the VS screen, right?
Yes.
Cool. Okay, so we'll start the discussions. I'll put this view here. 1 second, let me setting things up. Yeah. So we just started with the multi-threading discussion yesterday, right? Okay. So what we did was, so we'll understand some concepts. We'll keep writing a lot of code today for multi-threading, and what we'll do is to understand the concepts, we'll write the code and we'll see ki how this multi-threading thing is helping us in achieving better throughput, right? Okay, so before we start doing that, let's start. So, how did we discussed yesterday, like how to create the thread, right? We discussed about Windows and Linux, how they are different, but after C++11, we have a standard way of creating the threads, right? So once you have to create the thread, you include hash include thread and you create a thread like this, correct? So what will happen is once the main thread sees this code, it will start a new spawn a new thread, and this is the starting function that this thread will start from. The way the main thread starts from a main function, right? Similarly, every thread has to start from some function, and that is the first parameter you give to the thread, right? So this is the first function, and after that you can give any number of parameters that will go as a parameter to the function that is being called. So suppose if I have some parameter, so suppose this function takes two parameters, suppose int x and suppose a string y. So how will you pass the parameters to this function? So you give like this. So suppose I want to pass 2 and suppose I want to pass string as say Amit. So start function will be this, and these two will go as the parameter to this function, right? So if you want to print it, you can print it like this. See out, let's say x and handle, and I can copy this, paste it, and I can print the string also. So y, right? So you can pass the parameters to the function like this. So if I go ahead and run it, I'm in the same folder, right? Yeah. So cmake dash dash build dot. And if I run it, something is about, oh, I have not given the, why is this giving about runtime error? Why? Because what is happening here is this main thread is going out of bound till the thread is doing its work. So what we have to do? We have to do a
Fine.
join,
Yeah.
right? So what will happen when the main thread comes here? The main thread will stop until this other thread has done its work, right? So now if we run it, build and run. So Amit and 2 has been printed, which we have passed in as parameter, correct? Okay. So now what will happen is, so we know how to create a thread, how to pass parameters to a thread, right? So what other ways that we can create a thread, right? So this is one way to create a thread. What is the other way? So suppose we want to create a thread and give a starting function with the lambda function. So how we can do it? So we can give similarly, we can give t2 suppose, and we are passing the lambda function. So how we'll write lambda function is like this, capture parameters and the body. And suppose we want to do the same thing here. See out. And let's call it inside lambda, right? So what will happen? So the second thread will be created, spawned, and what is the starting function of this thread? This particular function, lambda function, this one, this. Is there any confusion with this? So you can start thread like this, you can start thread like this, correct? And suppose you want to pass the parameters to a lambda. How are you going to pass it to a lambda now? So suppose this my lambda again takes int x and suppose string y. So how are we going to pass it? Where we have to write the parameters?
Next to it.
Here.
No.
So this is
Yes.
the function. This just think as same like this. This is the function. So for us, this is the function, and after that we have to pass the parameters. So format, suppose I'm passing 20 and let's call it something else. Let's call it string, right? So and give it. And again, so because if we don't give a join, this thread will might be keep doing its work while main thread will exit. So we have to again give a join for this. T2 dot join. No confusion with this. So we build it, and if you run it, you'll see the lambda function also getting executed. Okay. Printing from thread func demo inside. See something that is printed from the lambda also, right? We have not printed the parameters, but you can see the print that has come from the lambda. Now what is happening is why this jumbled up print? Anyone, any guesses? Why this has been printed like this? Printing from thread, func, then empty, then demo space is there, then two endl is there, then two like why is like that?
Because they are context switching simultaneously.
Yeah, I mean, there is
Correct.
splicing between the two
Yeah.
splicing. So keep switching from one thread to the other.
Yeah, so while writing the multi-threaded code, like I also discussed yesterday also, when you are creating a thread, you will not be able to guess which thread will be doing its work, right? It will be a context which will happen between threads, right? And that OS will decide which thread I will give some time for this thread to do its work. Sometime I'll give this thread to do its work. So you'll never know. So if I run this again, there you will might see a different result. So if I run this again, can you see the difference? It was empty demo first. Now after that, empty demo again. Can you see the difference? Like before it was printing this, now it is printing this. Why? Because you never know when it switched the context. So suppose you might have printed this, but at this point of time, it switched the context and it started printing this. But while it was printing this, then it came to endel here. Then again endel here. So two endel happened simultaneously. Then it might have printed this and again printed this only. Then after this, so you never know. You cannot predict which thread will be given time by those, right? So while writing multi-threaded code, you should not assume anything. Is the takeaway from this? Right, that this will happen first or this will happen first. You never know. It might happen that the whole thing is get printed first, then only it will come to this lambda function. It can also happen like that, right? So do not assume while writing multi-threaded code, right? Okay. See, it also happens that we have created this thread first and then this thread later. It might happen that this thread will start printing its string first, because you might think that because we have started this first, it will start printing this first, then it will come to this, then it will start the thread there. It might happen that it has started but it has not started printing, while meanwhile this thread starts and then start printing first before the previous thread. It can also happen like that, right? So the
I
key
have one
takeaway is,
confusion. Uh,
sorry.
I have one confusion. Like how it will
Mm.
be like only T1 dot join is written. Like 26 is commented, suppose. So
Mhm.
how it will be the behavior? It is like T2 will run until the T1 time duration. Like how it will be?
What you are saying is only this what you're
Yeah.
saying, right?
Yes. Yes.
So what will happen is main thread will wait till T1 executes its work, but it will not wait for the T2. So T2 might be doing its work and then main thread will exit. So T2 will be left hanging somewhere.
Okay. Okay. Is it like if T1 running suppose 10 seconds running time
Hmm.
and
Hmm.
T2 is 20 seconds. So
Hmm.
T1 and T2 both will run up to 10 seconds and then stop. T2 will stop. Something like this.
Correct. It could happen like this.
Okay.
You are
Okay.
saying T1 is taking some 10 seconds time to execute it work.
Yes.
So main thread will
Yes.
wait till 10 seconds here, but you never know what happened to T2 at till that time. It might have taken more time, less time, but you never know. If we have not written this, it might also be possible that T2 might have done its work till that time and it has returned, right? So it might not give you error at that time. But
Okay.
anyway,
Okay.
if you do not join, the compiler sees it and it will start giving you, means at runtime, it will see you have not joined, or also there is something called detach. So it will start giving you error. Let's see if it gives error. If you build this and run this, see, it will give you error because it will detect that you have neither joined nor detached from the main thread, right? So if I do this, then it will work. Detach. So I'm telling, hey, main thread, don't wait for me. You can go ahead and do whatever you want. I am detaching from you, right? So if I now run it, build it and run, see, it will not give you error. But but after this, you are not sure whether T2 has done its work or not properly. So that is now up to the coder who is writing it. If I am writing detach, now I have to make sure that my T2 has done the work before main thread exits. Getting my point?
Okay. Okay. Okay.
So either you have to do join or you have to do detach. Otherwise, you will get a runtime error what we are getting.
Okay. Okay. It
Sorry,
is
I
not
missed
like
it. Okay, please.
Yeah, yeah, go ahead.
okay. Yeah. I was saying like it is not like if T2 is taking suppose very less time, but
Mm.
still it will show error if we have not done join or
Yeah, yeah.
detach.
It will show error. It will show error.
Okay. Okay.
No,
it will expect either you should detach or join with the main thread.
sorry, actually to interrupt. Okay, I
Mhm.
got disconnected for some time. Yeah, I just wanted to know in this, thread T2, you have passed this 20 and string, but that is not got printed. Why?
No, no, I have not printed only that. So if I print it, it will happen.
Oh, sorry. I did not see that piece of the code.
If I print it,
Okay,
it will happen.
okay,
Right?
okay, thank
Just I was trying to show you can pass the parameters to the lambda like this. So you do not get confused, right? It's think of it just as a function. Like from here to here, it's a function and then the parameters, which lambda is taking. Correct?
Hi, Amit.
Yeah,
I don't know whether you can hear me, but
I can hear you.
okay. Just a
Hmm.
quick question. Uh,
Hmm.
After we moved, so it's not like super related to maybe
Hmm.
multi-threading, but
Hmm.
after we moved to a multi-core world, is this
Mhm.
still holding true that right now when we are having these two threads, they are executing on the same core still, or are
Oh, no,
they
no, no,
all
no. They can go to a different core. They can go to a same core. You cannot decide it. That OS will decide.
okay?
Yeah, see, earlier when we were in the single core machines, earlier, very early days, it was sure that it will go to a single core because you have single core. But when you have suppose 8 cores, right? So OS can decide. So it is not like that only your process is running. There are many other processes are also running, like my VS Code is running right now, right? My Zoom is running right now. So they are also doing some computations and they are also executing code. So those will also be going to some course, right? So that core might also be busy. So it is the OS that will decide, okay, this core is free right now. Let me put this thread to this core, right? Are you getting the point?
Yeah, got it. Yeah.
But Amit, is this high performance computing in C++ related to this only to decide on which core you have to run it, or that is another thing?
Sorry, come again.
There is something called HPC, high performance computing, in
Mm-hmm.
C++, which I don't know, but I was thinking, is it related to how you have to schedule it on the course? Maybe if
No,
anybody
that
knows,
I am not aware of that you can decide whether which core to put in. See,
even I.
there is a way to decide. See, when you have GPU and all, no, so at that point of time, you have a way to decide. I want to execute this particular piece of code on GPUs. There is a way to decide that. There is a way to write the code for particular GPUs. But
Okay.
even if it's there, I am not aware that you can decide I want to go to this core or this other. I am not aware of that.
No, why I thought is because
Yeah.
when I tried to study high performance computing, it needed understanding of microprocessor and
Mhm.
assembly language also to some extent. So I thought maybe that is why I tried to get this connection. But
Okay,
anyway,
okay. Hmm.
but anyway, this I
For GPUs, it's possible. You can decide, okay, I want to compute this particular code in the GPUs. That is possible.
okay. And this sorry, I didn't get this. Detach is for what? T2 dot detach.
So you are telling this particular main thread what? So when the main thread comes here and it sees T2.detach, it is telling don't wait for the T2 to complete. Like main thread is not main thread will not wait for the T2 what is happening with T2. T2 will keep on doing its own work, and when it finishes its execution, it will just come out. So what will happen after this is T2 will this main thread will not wait for the T2 after this code. It will just detach and it will go ahead and do its work after that. Because for join, if you remember, I said main thread will stop at this point. It will not go ahead after this until T1 has done its work.
But that is the default behavior, right? Like when you didn't
Hmm.
mention T2 dot detach also, it just went and crashed because
What is suggested from the CPP is like either you have to detach explicitly tell me ki I am not waiting for the T2, or you have to join that I have to wait for the T2. CPP expects that ki you do not leave it anything by default.
okay, okay. So now it won't crash because of this
It won't
detach.
crash. It won't crash. So now it is up to the coder who is writing to see ki T2 doesn't go out of like process doesn't exit before T2 even has done its job, right? So it is useful, suppose in cases where you want main thread to do some other work while T2 is doing some other work, and you are sure that main thread will not exit. So suppose after this there is some UI thread or some big running task that will keep on happening in an infinite loop or something. So you know the main thread will keep on doing its work while you are leaving T2 to do its own job, right?
Yeah.
Suppose
So,
logging and putting logs to a different place like that.
so this detach is only called from main thread, or it we can see it in some other threads also being called.
But suppose in this particular, this is one thread function, right? So suppose I create one thread from here. Suppose I create thread from here, right? So I can say T3 dot detach, I can tell here. So this thread who has created it is not waiting for the thread for which it is created,
Got it.
right?
But
So I
but
can
again,
create thread from the thread function also.
yeah, but the same thing that although it's default behavior, but you're saying that language specifications is we have to be more explicit about it.
Yes, yes. You have to explicit, otherwise you will see the error. It won't run.
Okay.
Hmm. Okay.
Just
I have a
Amit,
question.
one
So,
quick. Okay, please.
Sorry.
we have T1.join. That means
Mhm.
T1 is waiting. Sorry, main is waiting for T1 to finish execution, and then main continues.
Yes.
And since we already have that join, that we don't need the second detach. Right? It's anyway
No,
waiting
this is
for
for the second thread. This is for the second
T1.
thread. This is not for the T1. I'm just giving an example that you can say a detach or join. So I can more specific correct way is to give a join only, that I want this T2 to finish its work. But there could be scenarios where you want the other thread to do its work while main thread is doing other work. It should not wait for the other thread. In that cases, you can do a detach. So you should also know this.
Okay,
What
and
is the
then
confusion?
what do we do about the jumbled outputs?
Jumbled outputs. Yeah, there is a way that we'll discuss. What should we do with the jumbled output? That we'll discuss.
Okay.
But you understood why the jumble output, right?
Yeah, because they're being executed simultaneously.
Not just simultaneously, they are switching the context. So one thread is trying to execute statement, but while it is trying to execute, it is preempted by another thread. So other thread came and that is started executing that, right? So you
Right.
never know which one will get completed first or which one will get completed second, like that. So every time you will run, you will see a different output depending on how they have been, like how they have been executed by the OS. Correct. So moving ahead, right? Good discussion here. Like, let's move on. Everyone, let's move on. Yes, yes. Or any confusion?
Amit,
Hmm.
so one question here. So basically, when we write T2 dot detach, right? So what will
Yeah.
happen? Let's say T2, like after that, there is no statement. So main will exit. And let's say by that time, T2 has not finished yet.
Yeah.
So
Yeah.
what is the behavior of OS in that case? Whether OS is going to terminate that T2
Yeah,
or
OS is going to terminate. Main thread exists means your process is completed. Process is completed. OS will try to take all the resources that process has been using. So thread and all will be executed. Done. Sim T2 will not be allowed to do the whole work only. It will be somewhere means abruptly it will be closed by the OS.
so that means it's not a graceful termination, right?
Yes, yes, it's not a graceful termination.
Okay, so the expectation is like we should use detach when we are 100% sure that our T2 will finish before main finish, right?
Yes.
Because if it finishes late, in that case the termination will happen, like not a
Yes.
graceful
So
termination will
suppose,
happen.
for example, if I show you, suppose I give detach here. So for example, but so after this main thread will go ahead, right? So suppose I have something like in the main thread, I'm doing something with while loop, right?
Right.
And like doing something here, like some work. So I know that after this, there's a while loop that is doing continuous work and it will keep doing it forever. So I'm sure that T2 will also keep doing its own work. I don't have to wait for the T2. So in that case, you can do a detach.
Okay.
Right?
Got it. Yeah.
Okay, so now moving on.
Amit, one last one
Yeah.
question.
Hmm.
I think when we are in two world, right? One is a single core and a multi-core. So when we say about a single core or multi-core, so the multi-threading is a one part. So that, as you told, it is a means context switching might happen. So that means one thread is executing, other will be suspended. Again, it T2 gets executing, and maybe that is the one thing. So the other thing is actually the concurrency, actual concurrency only we can see in the multi-core only, right? It is not
Yes,
in a
yes,
single core.
yes. Correct.
This is also like one question that I've been asked sometimes. What is like the difference between parallelism, true parallelism, and concurrency? They use the term parallelism to
Yeah.
describe the
So
black.
yeah. So actual parallelism you can only get on multi-cores, not on single. Right. So you have different CPUs to execute your code. Everyone is fine with this? Like everyone understand what we are talking about? Multi-core and all.
So for
Right?
single core, multi-threading is not beneficial, right? Suppose we have created so many threads in single core.
It is beneficial. Like, so suppose I was giving example yesterday. So suppose you have to write to a file, and then also parallelly you want to do something else. So while you are writing to a file, at that time, maybe CPU is not doing that much work, right? CPU is just waiting for that data to go inside
Yeah,
the
yeah.
file, right?
Okay.
So at that time you can do a context switching to other thread and then to other work, right? In that case, it is beneficial,
Okay.
correct?
Okay.
Yeah.
Or you are waiting for some input from user. At that time, if you are not doing a multi-thread, you will just keep on waiting for the user input. Meanwhile, your program is stuck. If you have to do something parallel, you can use multi-thread to do some parallel task meanwhile, right?
Yeah, actually, to just clarify, this is actually multi-threading will work as an IO bound task in the single core, but it cannot do a CPU bound. But if it's a multi-core, either a CPU bound is also possible and IO bound is also possible. So CPU bound in a sense, if you have a big for loop which will run from 1 to 1 lakh. Okay, if you have a CPU core, you can have a 10 cores with each like means at 1 to 10,000 in a actually one for loop,
Yeah.
and 10,000 to 20,000 in another for loop, like that 90,000 to 1 lakh in another for loop.
Yes.
Then you may have a parallel for each, which
Yeah.
actually work for you.
Yes. Okay. So we'll see those kind of examples also. Okay. So now a lot of discussion. Let's move ahead, right? We'll keep discussing a lot of things, right? Okay. So now moving ahead. So how other ways you can create a thread? So suppose I have a class, let's say call my class. I'm just giving a random name. And suppose I have some function, public. So these things you should know, okay, what are the other different ways you can create a multi-thread? What are the starting function that we give, no? Which all things we can use for the starting function for the thread. So suppose this is some member function, and we are doing some print inside this. Let's call it some print inside, call it my class, let's say, and then indel. So now what I want is, this is my class semicolon here. So now what I want is, I want this member function to be the starting function of my thread, but to some particular thread. So how I'm gonna do it? So suppose thread T3. So what should I write here? I want to make that starting function at this particular member function as the starting function. So how should I do it?
My class, then scope resolution, and then function name,
Okay.
and
Okay.
then you can pass the parameter.
Okay. So suppose I created a object of it, suppose, and then what will I do is, how do I give it? Yeah. So this is how you do it. Ampersand my class, this member function. So this is the starting point, and then if you realize, because this is the member function, by default some this parameter goes inside this, right? If you know the C++, right? Everyone knows this, that It is a hidden parameter that goes to every member function with this parameter,
Yes.
right? So we again have to pass this object. So we have to pass this object that we have created. So this object will go as a parameter to this pointer, right? Okay, and because it is a pointer, we have to give the address of it. Is this clear for everyone that this is how we can make the starting function as the class member as the starting function for the thread? So now for this thread, the starting function is this one, member function, with for this particular object, right? So for this also we have to do t3.join. Any confusion with this? How we are doing?
And Amit, and
Hmm.
if this member class function expects some argument, in that case we can put also, right, after that.
Yeah. After this, you can keep putting the argument whatever it needs after this. But you know, because what is the first argument that this function requires is this parameter.
Okay.
And after this, whatever the other arguments you need, you can keep passing it from that thread.
It
Right.
doesn't need to be static.
It doesn't need
To be static.
No, it doesn't need has to be static. If it is static, you don't have to pass this object.
Okay.
You know, right? If it is static, it doesn't take this parameter then.
Right.
Right. So only for it is a non-static non-static member function, you can pass the parameters. You have to pass this object parameter. Right? Is this clear? Like this should be a simple stuff.
So what is the meaning of hi Amit? What is the meaning of static function? Because on line number 40 and on above, you are creating thread T1. It seems like both thread are starting, correct? So it is a starting function, correct?
Starting function, I'm saying, not static.
Starting function. So what is the meaning of starting function? Because on line number 26, we are calling start func, correct?
Yeah.
So it is also starting function then 41.
No.
That's what I'm saying. This is
It is just a separate syntax, you are saying.
So static. I think he's thinking we are talking about starting function. starting. But
yeah, that's what I'm saying. Starting function. See, every thread when you create, you have to give it some starting function, right? From where this thread should start. So what I was asking is, suppose if I have to start give the thread as starting function as some member of the class, which is some member function of a class, how will you give it? So this is how you give it.
So if you want to call a member of the class, then it would be okay. I mean, like if we add some / comments above that line.
Okay.
On line number 40, like what? Yeah, this is what it is.
Starting function is member function of a class.
Thanks.
Right. And these are just some ordinary function. So this was starting is the lambda function. Right? So I'm giving you different ways how you can create. So suppose sometimes it can come that, okay, I want this function to be the starting function. So you can give it like this. And I'm just asking if you understand like why we are giving this ampersand object, even though it doesn't expect any parameter here. Right? So if you remember, after this, we give the parameters that this function requires after the starting function. So why we are giving this parameter, even though it doesn't expect any parameter here. Right? So this is clear. Can I expect everyone
Amit,
that this is clear? Yeah.
Yeah, Amit, this is clear. What you've shown so far is clear. What if these functions, so start func or this member function of this my class, what if those functions are to return a value?
Yeah. So I was just about to tell you. So suppose let's say a starting function, let's say it returns something int, right? And let's say you return some value, let's say 90, right? So what will happen? So the thing is, whatever you return from that starting wala function that the thread is using, the compiler just or at runtime it just ignores that value. That value is never taken by this function, right? So that is just ignored. You cannot do anything about it. Answer the question, right?
Understood. Okay.
So there is no meaning of, even if you return something, it's fine, but it will be ignored. That's it.
So
right?
once the execution path or the code path of some thread is complete, we don't expect that thread to return anything. That's it. Right?
Yeah,
I mean, within the
that's what
thread,
I'm
if you
saying.
have two functions, the functions can return something. Like it's say thread A starts from function A calls B can return something to A. That's fine. But
Correct, correct.
got it.
Yeah, so this starting function, if it returns anything, there is no meaning. Like it will be ignored. Even if it is there, if it's not there, it will be ignored. So the next part of the discussion was how do we pass something? How do we expect or how do we get the return from a function, from the starting function that we are using for the thread? Is there a way to do it? Right? So in this function only, suppose, so what we'll talk about is two things. So what we'll do here is in the start function, we'll take int string int y, and inside this, let's not return something now, and let's remove it to void. And what we'll do here is we'll change the x value to, let's say, something called 50, let's say, and we'll say cout value of x inside func is x, right? So this is done. And what else? Why is this giving error? Okay, anyway.
Output.
Oh, sorry. Yeah, this one. And what I will do is in the starting this thread, no, this we are using starting function. What we'll give is, so let's say we are taking int, suppose any number, int x equal to, let's say, 30, and we'll pass this x here, right? And if I see the value of this here, cout value of x in main thread, right? So, and let's print the value of x, and let's do ending. Let's do ending 2 times, so that means okay. I think it's fine. Cout is fine. Let's compile it. We'll see what is the problem. Okay, it's compiled. So what do you think will be the output? Let's forget everything after this. Can I delete this? It's fine, right? I can delete this. I can clear it, right? Okay, so this is the code. So int x is 30. We are passing this value, and we are printing this value inside the main thread also. And then what we are doing here is we are changing the value of x, and then we are printing inside it. So what will be the output? What will get printed?
50 and then
Inside the
30.
thread it is 50. In the main it is 30.
Okay. So if I just run it, okay, I didn't give. Okay, I removed the join.
Join is missing, yeah.
T1 void join. And okay, so value of x in main thread is 30, which was this, and this is printing, and value of x inside func is 50, so which is what we have changed. So it means what? If we are passing it like this x and amit, it is getting passed by value. Understand, right? If we are passing it by value, it means it is only copying the value and it is not actually the reference of it. Fine, right? It is getting passed by value. You all understand what is passed by value and passed by reference. I expect you all understand this.
Yes.
So if I change something in the function, that should get reflected to the caller itself. That is passed by reference, right? So how are we gonna pass something as passed by reference? So suppose in here, what if I do is like this. So for pass by reference, what we do is we give this, right? So now it is passed by reference, right? So now if I run it, now if I build and run it, what will be the output?
I think it is again same only. Inside the thread 50, in the main thread it is
Yeah,
30.
but anyway, it is giving compilation error. So what I'm saying is, if you have to pass something by reference, you have to do it like this. You have to tell कि I'm passing this by reference, right? So now if I compile it, it compiles. Now if I run it, see in the value of main thread, value of x in, so why can someone tell me why this output now? Value of x in main thread. So this is giving 30, which was 30 only, and now value of x inside is 50. So even if I pass by reference, it did not change. Why?
I think you need to move t1.join to before the cout statement and
Correct. So can anyone tell me what happened here?
Main
Clear case of multi-threading.
main first executed the x is equal to 30 and
Yes.
T1 executed later.
So what happened is, even before I change the value of x here, this main thread has already printed something, has already printed the value of x. And then after that, it might have changed the value of x. There can be a possibility that if I run 5-10 times, it might print the value of x as 50 also here. Right? So to make this proper, what I can do is, I want keep until unless the value change, I don't print it. So I can do is, I can join here. So what will happen is, main thread will wait here until the this T1 thread has finished its work. And what will happen if it's finished its work? This thing will get printed first. This value will have been changed till that time I would have come here to this cout. Is this clear with everyone? See, now it is 50 for both. X inside main also and inside func also. Did you get it? Did you get what happened? Why? Where to put join is also very important. You cannot just randomly put join anywhere, right? So if I would have put join after this main, I am not sure what could have been printed. But now I am sure what will print. Clear, right? Okay. So just to complete this, you can also use functor to as a starting function of the this thread, right? So how do you create a functor for a class? Anyone knows how do you create a functor? So what you
Operator
do is,
overload.
you do operator overload for this, right? And you can write any algorithm inside, whatever you want, like functor, right? So what I can do now is, this mask my class object that I have created, that I can directly use now. So suppose for the start, because instead of starting function, I can just directly use. Suppose I have created some my class object, and then directly I can use it like this object, right? So that becomes a function. So what function it is calling? It will call this operator, right? It will call this function, which is the operator overloaded function for the brackets. So any class which has this operator overload, it becomes a functor. I hope everyone understand what functor is. Correct? Moving on. Okay. So now moving on. There are some other ways that you can use, like std bind and all. That I'm like, it is simple only that you can use. Like you can std bind the function with the arguments, and then that you can use for the I will just show you syntax how you can use it. So if I have to use it like this, so you can bind, suppose this is some function and this function is taking these two arguments, you can do a std bind, and this now becomes your callable. So that this bound function you can use for the thread starting function, right? So this thing also you can use. Okay.
And then you
Now,
don't need to pass the parameter because it's already
sorry.
bound. So, and then you don't need to.
Correct.
Okay.
Right? Okay. So now we are done with this. So how we can start a thread? So now what we can do is, we can go ahead and see a few examples. So everyone is clear about pass by value and pass by reference, how we can pass by reference in the thread, how we can pass by value in the thread. Everyone is clear? Okay.
Can you show me where the operating overload is happening here?
Here, this one. This is the operator. This two brackets. This is the operator, and
Okay.
this is for the arguments.
Okay.
This is how we overload the operator, right? We give
Yeah.
operator and the operator what we have to overload. So
Oh.
any class which has this particular operator overload becomes a functor,
Okay.
right? Why? Because you can directly use the class object as it will behave like a function now, right? Okay. Okay, now moving on. So what we can do is, I think let's do let's do a one problem that we can analyze together. What will happen in this case? So I'm removing all this. Okay, so let's put some simple C out. Let's call it code started something. Started. Right? So now my problem statement is this. So let me write the code. Okay, so suppose I have some number const, let's call it int, and let's call it total data 100. Okay, and what I want to do is, so suppose I have a vector, of ints, which let's call it vec, which is of size this total data, and let's say it is all initialized with 1, right? I have included vector or not? I should include vector. Has include vector. Okay. So my problem statement is I have a vector which think of some data I have hundreds this much 100 of data and all initialized with 1. I want to do a sum of all the elements inside this vector. So there are a lot of ways that you can do it, right? So one way was that we were doing yesterday was, right, we can do simple accumulate, we can do. So that we can do, right? So the thing is we are studying multi-threading. So how we can leverage the multi-threading to do it more faster? So if you do accumulate, it will be doing in O(n) times, like it will take one element and it will sum everything up and it will give you the result, right? So suppose if I do it like this, suppose what I'll do is I'll create two separate files. Let's call it threading.cpp and let's call it threading.h. Okay, and inside threading.h, what we can do is I want to do this properly so that everyone understands ki what gain we can gain, what we gain we can get from that multi-threading, right? So let's call it threading_h, if not defined. So define this as define. Just be with me for a minute. As and def. And let's define two functions. One is let's call it, we are getting a sum, right? So with the sum could, let's call for right now, we do not know how big sum could be. So we are just giving long, and let's call it uh, get single threaded sum. Single threaded sum. And what we are expecting is vector of n of data, and we'll pass it as reference so that it will not copy it, right? And similarly we'll have another function that will say get multi-threaded sum. I want everyone's response here in this particular problem, right? Okay, it's okay. So now we'll define this to here in this, and we can include the one we can include is threading.h, this part, and inside this we can include vector. Okay, so vector is included, this is done. Now I have to give the definition of both of these functions. Okay, so for this, how can we get a single threaded sum? I can simply do a accumulate also, right? I can do a simple accumulate. Okay. So what we can do is long of result. What are you guys discussing? Pragma, if I remember, it only works on Windows. not on Linux. Long rest and accumulate. Accumulate is in hash include. Accumulate was in numeric, right? Yesterday we
I
saw.
think it's numeric.
Huh. And because we are using this, I think we should put it. I'm directly putting this here using namespace std. Fine. And now we can use it like this. So data dot begin and data dot, let's call it end. Sorry, data dot end, and let's give the initial value as 0. So this will calculate the sum of all the numbers that is inside the vector, right? And inside the main.cpp, if I come, what we can do here is, okay, so what we'll do here is for the single threaded sum, first we'll need to include that as include threading dot h, and let's call that function. So what was that? Single threaded sum, and we are passing our vector, which is vec, and it will give me some result, which is something called long result. And let's print this, right? So cout, let's call it single threaded sum, and let's print the result, right? And also what we'll do is, so similarly what we have to also do is we have to calculate for the this multi-threaded sum also. So long, let's call it raised to, and get multi-threaded sum, similarly pass vec, and let's also print this, copy, paste, and multi. Okay, so our whole boilerplate code is done. And now what I want is, I also want to calculate the time how much single thread is taking and how much multi-thread is taking, right? So to calculate the time, I'll just I think I have it here. Let's see. We get time or time diff. I put some small code snippets in my VS Code only, so I don't spend too much time. So I'll just put it here. Let's include chrono for calculating the time, and auto. So we start here. Function that we need to calculate time goes here. So this is the time that we need to calculate for. So it goes here, right? This is done. Auto end duration it will take. It will calculate the time in seconds. So for single threaded, it is done. We can print it afterwards. That is fine. After that, we need for the multi-threaded sum also. So what we'll do is, for this also, we'll get time diff. We don't need this now. We have already included. Let's remove this because I'm using the same variable also only for calculating the start and end time. And I'm putting this here. Let me know if you are not understanding anything. I'm just writing. I want to do this exercise properly. This will be a one-time effort. So for end also, I don't need to define again. So now I am calculating time taken also. We can remove this. So end minus start is done. Time taken dot count in seconds, and multi-threaded sum is this. Multi-thread, I'll just put it for multi-thread, right? And for time taken for here is for single thread, right? So my whole thing is done. I will be able to calculate the time. The only thing left is how should I break how can we leverage the multi-threading here? Like if I have to calculate the sum of all the elements inside the vector, how we can leverage the multi-thread? Now I want all of you to pitch in. So this is the code that we have to complete. This one.
I mean,
Yeah.
my idea was one of the ideas is that
Hmm.
you basically think that data vector consists of two hulls, and then you so you basically take data dot size by 2, and then pass the first hull to one thread and the second hull to another thread, and do an accumulate inside that.
Okay, but how do you know that only 2 threads will be good enough?
Yeah,
How about like doing it with 4 threads? Right?
Yeah.
Anyone else? Like any other thoughts?
First, we need to calculate the number of cores we have, and we have to find the optimum number of cores we can use, because if we use too much threads also, it's because of context switching, the performance will get affected.
Correct. So he is telling that we should first know how much core we have on our system. So suppose my system is 8 core. So I will spawn 8 number of threads. So at least I know if it is at least for each particular core, 1 thread can go. So it will not have much contention like when we are doing context switching. No, it will be minimized. Right? Are you getting the point? Like if I go ahead and say I will start 40 threads. So a lot of context switching will start happening between threads. So if there are many threads for each core, at least I can, best thing is I can put 1 core, or maybe not even 1 core is not good enough. You can just go ahead with the 2 threads per core. But that is the optimization people have seen that gives the best results. 1 thread per core, or max two threads per core. Right?
Amit, actually, this kind of question I have been asked in Adobe once a day. What they are more looking into, like, how do I utilize the cache memory instead of just breaking down the elements of the arrays into multiple cores, right, by threads. But they rather want me to go into deep of the how cache memory can be utilized to save the context switches between the.
Okay.
Some more line.
Okay, that's a good question. We'll discuss caching memory utilization. Okay. I'll note it. I'll get back to you. Okay. I understood what you are asking. Okay, going ahead. So what we'll first decide is how many number of threads we have to create. Who asked this question? I just want to know the name. I can get back to you.
Rahul Sharma.
Okay. That's a good question. Everyone note this. How can you utilize the caching memory of the OS, right? OS also has their own cache, right? So how you can utilize that when you are doing such kind of work? Okay. Correct, Rahul. I'm giving I've understood correctly, right? Okay. So how do we calculate the number of cores? So we have a function that is given by thread. So thread, we have to include thread here. Has include thread. So thread, and then we have hardware concurrency, and I think that's it. So this will give me how many number of cores I have on my machine, and that many number of threads I will create. Fine. Everyone understand what we are trying to do here, right? So we are going to create number of threads, how many number of cores we have on our system. So if your system has suppose 16 cores, I am going to create 16 threads. If my system has 8 threads, I am going to create 8 threads to compute the result, right?
But this efficiency, what you said about 1 or 2 threads per core, that would still hold good, considering that there is other applications also running who are also multi-threading.
Yeah, see, like people have realized that after doing a lot of like lot of things, a lot of experimentation, people have realized this is where they get most optimized result. So it is better to go with. So see, any application you make, no, the number of threads, how much thread you should create, it always goes with little bit of experimentation. People send a lot of data, then they will tweak a little bit. They will start with 8 thread, they will start with 10 threads, and they will realize that, okay, this many number of threads giving my system the optimum result, so they will stick to that many number of threads. That's how the real systems are done in companies or enterprises also.
Yeah,
They
but
will do a lot of experimentation.
Means I'm just asking from interview point of view, like if somebody asks that, but it is always a consideration, right? Like whether other applications are running, then definitely it will have an impact.
Yes.
Yeah.
So mostly what happens, suppose you have some web application where you're running servers and all. So you will mostly realize that there are not many applications will be running. That will be pretty isolated systems where your own server is mostly running. Mostly one or two other processes at most, right? Not like my general system that my VS Code is also running or Zoom is also running. It won't happen like that.
Correct. So dedicated.
Yeah, dedicated. Right? Okay, so going ahead, so what we'll need is we have to create that many number of threads. Okay, so one more problem is, so suppose visualize like this. So suppose you have a big data inside in your vector, right? And you are segregating. So suppose first we'll take about suppose 100 vectors, and suppose I have 4 cores. So now what we are trying to do here is we are trying to calculate the sum of first 25 with one thread, another 25 with other thread, another 25 with other thread, another 25 with other thread, right? And we'll get the sum of each of their 25 things in their own particular, somewhere I have to store the result, right? Otherwise, how will I know what will be the total result? I have to store it somewhere, right? For each particular thread, the result. Are you getting the point what I'm saying? For each thread, what it is calculating, I have to store it somewhere so that at the end, I should add them all up. Got it, right?
Yeah.
Yeah.
So for that, what I'll do is I'll create something called to store the result. What I'll do is vector of, so each sum how much it will be, I don't know. So I'm just keeping vector of long for now, and I'll put res, and how much res I need.
Num threads, basically, right?
Correct. Number of threads, and just I'm starting this with I'm initializing everything with 0. Is this line clear for everyone? Right? Because it is long, I'm taking, I'll just put it like this. Okay. So after this, what I'll do is discussion in SO. Okay. After this, what I'll do is I have to create that many number of threads. So what I'll do is vector of threads. All those threads I have to put in some vectors. I'll tell you why. I can create it separately also, but I don't know initially how many threads I need, right? Because these many number of threads I have to create, num threads, right? Yeah. So initially I don't know. It could be 8, it could be 12. So I'll keep a vector of threads. So let's call it threads. And what I'll do is now is I'll also have to decide what will be the chunk size of each thread that will be computing the result for, right? So what will be my chunk size? So let's say long chunk size. What will be my chunk size? Anyone?
Data dot size divided by number of threads.
Num threads.
Okay. Correct. Now what I can do is I can loop for int I equal to 0, I less than number of threads. So these many number of threads I'll create, and I plus plus, and I'll go ahead and create that many number of threads. Okay. So how do I create it? So okay, I had to discuss one thing yesterday, but I forgot. Somebody was asking about pushback and emplace back, right? I forgot to discuss that. So here we can discuss this together, right? So what we'll do here is, so to create a thread, what do we do? So we do it like this. So suppose thread T, and we can do it. So we have to give it some initial function to start with. So let's give it some initial function. So I can call this function as, let's say, partial sum, right? And what does it take? I have to give it the data to calculate. So vector of int of data. And I should pass it with the ampersand. What else do I need to give this to calculate the partial sum so that each thread will calculate only its own chunk?
The size, chunk size.
Okay. So I'm giving the whole data, so I can just give it the starting point and the ending point, right?
Yeah.
Correct? Okay.
Yes.
Okay. And what else? What else does it need? Anything else?
Needs to know where to
result.
store it. So pass some variable. Pass basically the results vector where you want to store the result.
Yes, because remember that we need to store the result somewhere, right? And this partial sum cannot return anything, right? Because this is the starting point of function, and we have studied that anything that is returned gets ignored. So we have to do something in the parameter only, right? So we can pass something as reference that in that if it stores, I can get back the result from here. So what we'll do here is what we can do here is we are storing the result in, so let's say in percent result, and we have to do the sum inside this. Correct?
Result should be long,
Yeah,
right?
yeah, correct. It could be long now, it could become long now, right? And what we can do inside partial sum? What we can do inside partial sum? How to calculate?
We can do accumulate.
Yep, accumulate we can directly use. And what we'll do? Data dot begin. Come on, tell me. Data dot
Plus
begin
start.
plus start. Right? Then data dot begin plus end. Then
0.
0. Let's give it like this. And where do we have to store the result? In res.
Yes.
Correct. So this will calculate the sum for its own chunks, right? So now we were here. So we have to give the starting point as partial sum. This is the one. Now the second parameter is the data vector that we have to pass. So we have to pass it as reference, right? So we have to pass it as reference and the data. And then we have to pass the starting point and the ending point. How to get the starting and ending? Let's calculate. So what is the starting point for anyone? What is the starting point for any particular chunk?
It is I into chunk size. I plus 1 into chunk size.
Starting point. So suppose for the first loop, if I'm at 0, so my start should be at 0 only, right?
I into chunk size. Yeah, I mean, yeah.
Right. And what is the end? What could be the end?
I plus 1 into chunk size. I plus 1 into chunk size minus 1.
Okay. Why minus 1 again?
Because it's you don't. So I plus 1 into chunk size will be the start of the next subarray.
Okay. But because it is starting from 0, no? So I plus 1 dot chunk size is good enough, right? It will start from there.
Oh.
This one. But it could happen like suppose you have suppose you have 4 threads and you have let's say 70 data, right? So how we are going to divide 4 by 70? So each chunk is how much? Each chunk is how much? Say 17. So something around that, right? So the first chunk will get 17, but the last chunk has something that it will have to accommodate, right? If it is lesser or small, if it is lesser, then it has to note that much, or it will go out of bounds if it directly do I plus 1 into chunk size. So what we should do is we should check if I is equal to number of threads. So if we are at the last, so at that point of time, we should do is what should I do at that point of time? I should take the last one.
Yeah.
Otherwise, take this. What do you say?
Yeah, makes sense. Yeah.
Right? Because see, it can happen like 40, 40, 40, but the last remaining is 20 only. Could be something less. If I give y plus 1, then it can go beyond bounds, like array out of bounds. So to check that, I am just checking if it is the last one, then go till the data dot size, whatever you have. Otherwise, you do I plus 1 dot chunk size. Right? So these start and end, we have to pass, right? And are we passing it as no? Simple pass we have to do. So start and then end, and then we have to give the result. So what we have taken for result? This one, right? So we have to pass. What should we pass here? Tell me.
Reference
For
of
the result.
res dot
Reference.
Ref of
I.
rest of I.
Correct.
Yes.
Everyone gets this. So every data, every value that is calculated will come in particular race of I. So first chunk will be in race of 0, race of 1. Second will be in race of 1, like that, right? Everyone gets this. So what after this? What after this we have to do? Tell me.
Join.
Correct. If we don't join, this thread will go out. They'll go out, and the other threads will keep calculating, right? So what we can do is thread inside threads.
First, we should add thread T to threads. We haven't pushed it to threads vector.
Correct. So we have just created it, but where are we pushing it? Inside, right? So we have to do is threads. So then only we will be able to join like this, right? So we have to push on this T. Is this okay?
Amit,
Everyone
can't
is
we
clear?
do thread.join after creating the thread directly?
We can do. You are saying hit here only, right?
Right. Instead of pushback, we can directly say thread.join or t.join.
We can. But I am doing it like this so that we have threads with us. So we can directly do join like this. No, so the problem will be there is problem will be. See okay, that's good scenario. So if I do t.join here, what will happen? Tell me.
It will become synchronous.
Tell me what will happen. So if I do t.join, what will happen is it will go and calculate this particular sum. It will come here. Then only it will go and create another thread.
It will get suspended. It will keep calculating each chunk sequentially.
Correct. Not parallelly. So the thing is, the moment main thread will see join, main thread will just stop here. Until unless this partial sum has been calculated for suppose first chunk, it will wait, then it will go ahead again and then create the second chunk. Then it will wait. It will become sequential. It will not give us any gain. So we cannot do it here. Good question, but you see why we cannot do it here, right?
So what is pushback here? Sorry.
So this threads is a vector of thread, right? So we are creating all the threads and pushing it inside a vector.
Okay.
Right?
Okay.
So the other ways we can do is what we are doing here is we are creating a thread and then we are putting inside the this thread vector, right? But what will happen is because of this, every time we are doing this, we are creating a copy of the thread and then we are putting inside the thread. So this is something we can do it better, right? What we can do here also is instead of doing this, we can create directly thread here. So why you guys get it, right? Why this is not like a good thing to do a copy every time. We are creating and then creating copy and then moving it to the thread vector. Instead of that, what we can do is like this directly.
But we can do move, no?
But 1 second, I'm showing. So instead of this, we can directly do this also. Push back and we are creating inside this only. Create thread and then what will happen in this case? So if we are doing the earlier one, what was happening was we are creating a copy and then moving it to the vectors. But with this, what will happen? It is now doing a move. Right? So it is creating a temporary object of thread and then moving. So when it is temporary object, it does a move. Remember these concepts. Temporary objects are moved.
Yeah, but we could have used std move. Would it have the same effect? Std move with t.
Again, but you are still creating and moving, right? Either copying or moving. So I'm telling there is still a better way to do it. Okay. And that there comes the in place back. So what it will do is instead of now creating a thread like this, you can remove this and remove this. See, so now in what does in place back do? Instead of creating and copying or moving, it directly creates where it has to store. There only by using this as the parameters. Getting my point? So that is why in place back is better than pushback in this scenario. And somebody was asking, right, when to use in place back and why in place back is better than pushback. Why? Because you don't have to move or copy in case of pushback, we do a copy or move, but in placeback, what it does is it directly takes the parameter as a constructor and creates the object and put it in where it has to store it, right? Are you, is it clear why in placeback is better than pushback?
So is it like just calling the thread constructor? I mean, you
Correct.
don't even need to call the thread
I'm
here.
just giving, see, in placeback, I'm nowhere I'm writing thread. I'm just giving the parameter. So by default, this particular vector, because it is vector of thread, it will know, okay, I have to use this as a parameter to create thread. So it will create the thread there only where it has to store. Create object somewhere else only, right? I just need it to be put inside the vector. If those are the cases, if you do not need the object somewhere else, you can use the in place back. But if you require to use an object somewhere else and then to put it in vector also, then in that case you have to use pushback. Getting my point? Is this clear in place back and where to use pushback? This is very common question that gets asked. We should have done yesterday only during STL, but it's fine, right? We can do it today also. Now it is more clear because we are using it. Why we should use in place back instead of pushback. Create? Done, right? This is done.
Yeah, but I still have a one actually the small doubt here. Why it should not be this? You have that I plus 1 star chunk size is there, right? Should be minus 1, or I had just one small, because that will overlap, no? In the next, it doesn't.
Just
Like,
see. So
like the
suppose
last
first let's see. So our chunk, suppose we have 100 data. So our chunk size is how much? 25. Suppose giving that 4 number of threads.
Yeah.
Chunk size is 4. So suppose first loop comes. So our start is 0 and end is what? End will be I plus 1 into chunk size. So end is what? 1 into chunk size. So 0 to 25. So it means that then you are saying it should go to 0 to 24 is what you are saying.
Yeah. Because what happens again that actually in the next time that
So 1
25
will
goes.
come, 25 will come. Correct.
One
I think you are correct.
overlap might happen.
This you are saying, right?
But actually,
Right.
like when we use standard accumulate, we give any
You
vector
give
dot
end.
end. It is not
Yeah, you give
actually
end,
going
which
to
is
the end element, but one after end. So I think this is correct.
it's
Okay.
one
Very good
beyond the
discussion.
last index of the array, right? You always pass that.
Correct. So when you are seeing this accumulate, no? So when we are giving data dot begin, this bound is taken, but the second bound which is outside the bound of that from till where we have to take, like this bound is not taken. So 25 is correct. We have to take till 25. Otherwise, if we take till 24, then it will calculate from 0 to 23 only. Good discussion.
Okay.
Got it? Why not -1? Even I
Yeah,
got
it
confused.
will
But
only,
yeah,
it will
correct.
only
Because
take
of this
the
accumulate.
last one. Okay, understood. Because of the accumulate. Yeah. The
Yes,
last
correct.
is
Last bound is not taken. It has to
not
come
taken,
before that
right?
one.
Then
Yes.
it's correct. I'm sorry. I got a little confusion with that one. Okay.
Good. So now after this, we have done join. This is done. And now what we have to do after this? What we should do?
Do we have one function call like in Windows there is a API wait for multiple objects. In Windows, like say, and wait for single object for one thread, and if you want to wait for multiple, so you have something.
Yes. We don't have that API here, I think.
Yeah, but you have to learn a loop only to join for all the threads.
Yeah, you can do this, right? Okay, so now after this, what should we return?
I think you can do one more accumulate on the result res vector.
Okay, accumulate. Accumulate of what?
Res dot begin, res dot end, and 0.
0. Let's see. Now we are done with this multi-threaded part also. So we come to main.cpp. Anything is still left? I think we need to change this CMake list. I think we need to put sources as threading.cpp also. Correct? Let's see if it builds. CMake. This gets generated build dot. Okay, some error. Cannot open threading.h. It is all in the same file only, no? So let's see where it is not able to open. Okay, I have given it like this. Threading.h. Get single thread sum. Let's build it again. So what is this telling? I have to return this. So return this. This is done. This anyway, I don't have to return anything, and I'm returning it from here. Okay, this is warning. Let's see if it runs. So, okay. So now see the time. Time taken for single thread is like 1 into 10 to the power minus 5 something. But time taken for multi-thread is 0.003. So this one is smaller, right? Single thread is taking less time than multi-thread. Why this? We thought that our we were using multi-thread to minimize the time, right? To calculate the sum. But our single thread has outperformed our multi-thread. If you see the time. Result is same for both.
I think the overhead of creating like whatever 8 threads or whatever here is, I mean it's outweighing the benefit,
Yes.
right? If the array were very large, then probably yes.
So you see, suppose, so that's why this effort I wanted to put in this, that you understand that lot of things. So how can you use multi-threading? How can you use multi-threading to do calculations like this, right? Parallelly. And also to understand that multi-threading is not some silver bullet or something. Like it will always be better than single thread. That you should understand. You should, if you are knowing pros of multi-threading, you should also understand the cons of multi-threading, right? So it's not like you go there and just use multi-thread in every scenario, right? So you should also understand that there is a lot of context switching that happens when you create thread. When you create thread, then some resources has to be allocated by the system, right? For your OS, and that is still itself create takes time. For multi-threading, these things didn't happen, right? The main thread went on and did the sum of all the 100 numbers. But for multi-threaded, what happened? It created that many first it created threads. While it would have been calculating, some context switching might have happened, right. So you should understand the cons of using a multi-thread. It's not like multi-thread will always be better than single thread. That was the point of this discussion. But suppose now, so suppose if I increase this, suppose I increase it to 1000. Now we have 1000 numbers in our vector, and let's build it. What do you think? Which one will be better for 1000 numbers? Let's see.
I think still it is single threaded only.
Single thread is still better. Let's increase more. 100. So now at 10,000. Let's see at what point, at any point, if our multi-thread is better or not. So now for single thread, still no. Let's increase 2 times more. Now let's build this. And now let's run it. So now if you say a single thread is taking 0.003 and now our multi-thread is taking 0.002. Little bit more, little bit less time for multi-thread, little bit. Can you see now the gap is filling, right? Now what would happen? Because it is a large number, single thread would have been doing simple sum for every number, but our multi-thread would have been doing sum for this, sum for this, sum for this many chunks, and parallelly computing everything, right? Now if I increase more, suppose more numbers, one more zero, so let's see how much better I can get. And if I run it, if I run it, Now see, our single thread is taking 0.011, but our multi-thread is taking 0.005, like twice more. Our multi-thread is twice better than our single thread. Can you see it? Now we have overpassed our single thread. Suppose we give one more 0. Now our data set is very, very large. And if I build it, run it, I think it will take some time also. So now our single thread is taking 0.2 seconds and our multi-thread is taking 0.06 seconds. Now how much time better? Around how much? 3-4 times maybe? 4 times around?
Yep. Yeah.
Yeah.
Correct? I'll just do it with one more 0 and then we'll move ahead. And clear this, run this. Let's see how much time it takes. So a single thread will take much more time now. So earlier it was 4 times, our multi-thread was 4 times better. Now let's see how much it is better. So yeah, so single thread is 2.18. So our single thread took 2.1 second, but our multi-thread took 0.4, which is somewhere around 4 times only, I think. Okay. So now you understand when to use multi-thread and when not to use multi-thread. So you should also keep in mind the things that can go wrong in multi-thread, like context switching will happen. So those things take time. Creating thread takes time. So those things that you should keep in mind until unless it is big data set you are going for or something that will take a lot of time, you should not think about multi-threading is what the point of this discussion was. Right? You should not just take anything and just put multi-threading into it. Correct? Okay,
Yeah,
so now
Amit, one thing. Yeah,
Hmm.
that's yeah. This is really a great this one. And the one more thing is like if so now it is a okay, since it was actually an adding kind of a thing, not very much like a CPU intensive activity. If suppose if you have something right. Getting some like means okay, prime numbers from 1 to 100 crore or whatever thing. Then if we make a threads and all, we can even see like means 10x or something like
yes,
that.
yes,
This one also.
yes. We can even get a lot good throughput using multi-threading if you have a lot of CPU intensive calculation that is going on, right? So that was the point of this discussion to see ki whether that say multi-thread is still better for your situation or not, right? Okay, so now moving ahead, so we'll discuss something called we'll quickly now discuss and go ahead with discussing.
Amit, can you tell like what are some like in companies how do they use multi-threading in which applications? General
Companies use
examples of
like
here
the
we are
kind
just
of
adding numbers, but
yeah.
what?
So the best example will be like suppose you have some UI or some projects that has some UI. So there people will use multi-threading because one thread will always be occupied for the UI part. Other threads will be doing some background task. Or suppose even if it is not UI, suppose you have a project. I'll give you a simple example where you have some logging thing going on. You have logged something and that logs has to be transferred to some other machine, right? So you won't do it in that main thread. So because if you do it in main threads, think about it. Like you have to read all the data from the log files. You have to put it on the socket, and then you have to push it to the other machine, right? So you will not block the main thread for this task, right? What you want is your main thread is doing the actual business logic, not the logic for the logging and then putting it to the some other server. For that, you will use multi-threading. This is very good example, right? Are you getting the point?
Yeah, got it.
Right?
Thanks.
So the places where you can actually parallelize things, like one thread is doing this and other thing is doing this, you can parallelize things, then you can use multi-threading, right? And most of the
Okay.
time, companies use multi-threading because these things
Amit,
will,
yeah,
yeah.
I guess that like if you have like any, I guess like any website, like let's say like a like the Google search engine is like super busy, so the web server is probably like multi-threaded, right? I mean, it will have like probably several threads, one thread which is responding to some request, another thread at the same time is doing something else, and so on, right?
Yes, it will be. you will see when we'll create the web server, no, you will see how we'll use multi-threading to respond to different clients at the same time.
Yeah, on logger part, I am also having one example, a real-time example, which I have faced in my project. I was been assigned to develop a rendering engine, and we have developed everything, but we are not capturing the logs. And the thing is, like, we need to print on console, plus we need to replicate the same thing onto the file somewhere we can store, right?
Okay.
So client wanted to see the logs at runtime on console, as well as we also wanted to gather the logs on the file system.
Yeah.
So as soon as we have used the SPD log as a logger library, and then our application rendering got slowed down because everything was happening on the same page. So yeah, this is where we have used the multi-threading, and then to speed the rendering process, we have segregated the rendering process thread and then logger threads, and inside the logger thread also we have also used the multiple threads. So this is one of the examples in GitLab.
Yep, correct. Rama is saying threads can be pre-created and put inside pool. That we'll discuss in next week. I mean, when we'll be discussing thread pool. Thread pool, I will not discuss too much in the class because I'll tell you where to see the video and all. Because I've already created a pretty nice video on thread pool on YouTube. But I'll discuss a little bit about thread pool on next class. Yeah. So moving ahead. So I'll just copy paste some code now, and because I want to move a little faster. Okay. So it will be simple code only that you can see. One sec, that I'll format. Yeah. So there is two things. So one is print safe. So I'll remove this log for now. Okay, which is doing nothing. It is taking a message and it is printing on the console. And there is a thread function. What it is doing is it is looping for 5 times and it is giving this. It is calling this print safe function, right? So it will print thread and then one is running like that. It will do. And from the main, what we'll do is it will create 2 threads. This code is simple, right? No need to like write from scratch or anything. So I'll remove all this code. I'll comment it out for now. This one. And I'll put it here. So I'm creating 2 threads, right? So I'm creating two threads and giving the starting function as this particular thread function, and I'm passing some kind of ID. So ID1 and ID2. And if I run it, what will happen? What is going to happen? ToString is not a member because we have to include hash include string. Okay. So clear, build, and run. Sorry, run. Okay, so now can you see what it is getting printed? So thread 1 is running, thread 2 is running. Then the first code that we were running, two indels at the same time. Then thread 1 is running. It is all jumbled up, right? So what can we do to like properly print one thing at a time? Like if this particular thing is getting printed, this one. No, not this one. So I want this whole line should be printed by one thread only at once. Like it should not be like I have just printed till message and then other thread preempts and the other thread again prints its own message, other thread preempts. I want this whole line to be, if one thread has taken access of this line, this whole line should get printed at once by that particular thread. So how can we do it? That comes the concepts of synchronization, right? If I can spell it right, synchronization. Okay. So how can we do it? There comes the concepts of, yeah, critical section. Okay. What is critical section? What is critical section? Anyone?
Critical section
Quickly.
is some piece of code that only one thread or one process should be allowed to execute at a time. Like
Yes. So any particular shared piece of code that supposed, so this particular, if you see this particular line, right? And if you see, I have given this the starting function. What can happen is these two threads will try to access this line at the same time, right? So I can say that this particular line is the critical section, right? So this critical section is what? So if multiple threads are trying to access the same code, so that particular code becomes the critical section. That could be one line of code, or that could be n number line of code. So that becomes your critical section if it is getting accessed by n number of threads parallelly, right? So for us, for at this point of time, this particular line is the critical section for us, because this will be accessed by these two particular threads at the same time. So that we have to safeguard. We want this particular line shall only be accessed by one thread at a time. For that, what we can do, how can we save our critical section? By something called mutex. So there are n number of synchronization methods we are given. And what are all different number of synchronization? One is mutex. What other things are there for synchronization? Can anyone tell me what all things? Mutex.
Atomic.
Sorry.
Atomic is one.
Atomic. Okay. The voice is not proper. Okay. Semaphore is also one. Okay.
Barriers.
What else? Barriers is also one. Correct. So similar to that, latch is also there. What else? We can also control or signal your thread through using control. What do you call? Condition variables.
Yeah. Condition variable.
Correct. And what else? Is this okay? So these all can be used for synchronizing your code among all the threads that is trying to access the critical section, right? And then first we'll look at the mutex, how we can use the mutex. So first we'll look at mutex. So what is mutex? Mutex simply means mutually exclusive. Like if this is accessing, this other thread will wait, right? So how we do it? So we have to first, right? We have to include mutex for it. I'll give a simple thing. Mutex has include mutex, right? To use mutex, you have to do include mutex. INCLUD, include mutex. And then you have to define the mutex. I am removing all these codes now. Start func and all. Okay. So what we can do is I can just define a mutex. Let's call it mutex. Let's call it empty. And what I can do is at this point of time, wherever my critical section is, I can do empty dot log. Right? So what will happen is, so suppose particular thread 1 came here, and it will, if it sees this code, what it will do is it will lock itself. So any other thread, if it comes here, it will check is empty, is this particular mutex empty, has been locked earlier by anyone else, right? If it is already locked, this other thread will just keep on waiting here. It will not move after this. So only one thread will be allowed at once to access this particular line. Why? Because one thread will come here, it will take the lock, and if other thread comes after this, if it comes to this particular line, it will say, see ki another thread with this particular mutex has already been locked. So I'll just keep waiting until other thread has released the lock. Right? So what will happen? Only this line will get printed at once by only one thread. It will not happen ki in between the lines the thread will preempt. Ki other thread will take the control and this thread will go. This thread will leave the control, other thread will give the control. It won't happen like that until unless this has been released. So when should we release the lock? We should release the lock after we are done with the printing. So we can say directly unlock. Right? So this is the simple code that you have to write to synchronize your critical section. And you should also keep in mind for the critical section is you should minimize the number of code that is inside the critical section. Like suppose if I do like this, I know that this is my critical section. I can just go ahead and I can do a lock here also, right? And I can put a lock here also, suppose. What is bad about this code? Can you tell me? Anyone? Than previous code? What is not good when we are writing a lock for the whole for loop?
I
What
think
will happen
it
is?
is. I think it is same as almost like a single thread, because all operation one thread will continue up to that other thread simply has to wait.
Yes.
It is, yeah.
Yes, you should also remember this way properly. Like when you are doing lock and unlock, you should know, you should minimize your critical section. When I'm saying minimize, what does that mean? The number of code that is inside, which is getting accessed by the threads parallelly, should be minimum as minimum as possible. You should not like put the whole function inside a lock. What will happen in that case? You will not get the advantage of the multi-threading only. It in fact it is getting bad than the single thread. Why? Because again the context switch, creation of threads and overhead is there. So you should minimize the critical section. So what will happen in this case is one thread will come, it will take a lock and it will do all the 5 statements until it is done. It is not unlocking. So other thread, it will wait until the thread has finished all the 5 prints. But here, if I give the lock here, what will happen? If I give the lock here and unlock here, what will happen? One thread has printed, it will unlock, and then it can happen that other thread now can take this particular statement and do the print, right? So minimize the critical section, right? And this is how you can synchronize the your critical section using the mutex, right? Okay. So going ahead with mutex, so this is some simple mutex that you can use, but what can go wrong with this mutex? Suppose I forgot to do an unlock. Suppose I have something really big code here, some really big code that I have written, and somewhere down the line I have to unlock, but I forgot to do unlock. So what can go wrong? The thread will keep the lock for infinite time, right? It has never unlocked. So other threads just keep on waiting. It will never get the chance to execute that particular line of code, which is inside the lock. Right? Are you getting the point? So what happens when you forget the lock? For that, CPP has given us a good thing, which is called, what it is called? Anyone?
I think like a unique lock or something.
Yeah. So
Unique
first let's
lock,
talk about log guard.
Log guard, yeah.
Right? So log guard of, like we will say some kind of mutex. And let's say we'll write it like this. I'm just giving the syntax, and let's say it is some mutex here, right? So instead of using mutex, what we can use here is log guard. So log guard, and it is all inside the include mutex only. So mutex, let's call it log guard, and you need to put mutex. So I've given empty, right? Now
Amit,
what? Yeah.
in the
Tell me.
previous case, like when Mutex M1 was there, lock unlock. So in that case, like this printing will be done like thread 1 will print 5 times and then thread 2 will print 5 times. Yeah, on thread 1 will take suppose 0, then thread 2 is taking
Which one? Where I was giving the here or in
or
here
inside
also?
the for loop when you are giving now. So
So if so similar to this. So suppose my block is here, right? So what will happen is, so suppose one thread came and it will print this whole line. It will not be preempted while it is printing this line. And once it is it is unlocked, once it is, so I was giving the unlock here. I was giving the unlock here. So once it is unlocked, other thread can come and do the print safe. So it can happen that other thread will come and it will do the printing.
other
It can
threads will start from 0, or it will be like next 1 or 2 like that.
No, it will start from 0. It will start from 0.
So every thread will be completing 5 times, right?
Yes. Remember, the thread has its own local storage or its own stack. This will not be shared until unless you have a shared memory or maybe global memory. These particular which are on stack will not be shared.
Okay.
Both the threads will see its own stack memory.
Okay.
Is this clear with everyone? Is there any confusion with the stack memory of own threads? Like each thread has its own stack memory. So whatever the local variables are there, each thread will have its own local variables. So this I for those two threads, this I will be different. Right? Is this clear?
Amit?
Yeah.
Yeah, just one thing. Actually, I lost you a little bit in the beginning when you had started talking about mutexes. This thing which I see, the display that I see on your console, where it says thread 2 is running, and after that immediately thread 1 is running. So it didn't print endl, I think, right? So basically thread 1 preempted thread 2 at that time, right? Is that understanding correct or no?
This one you are telling.
Yeah, the one below the one below, where there is one line, not that one. Yeah, that one where your cursor thread 2 is running immediately, then thread 1 is running. 2 lines below.
This one? Thread 1 is running and the three. Okay, this one thread 2 is running and with thread 1 is running. Yeah. So at this, see, what could have happened is here it would have printed thread 2 is running till this, and then it preempted, and then the other thread came.
Got it.
Then again it printed thread 1, and then again the first thread indel happened, and then the second indel happened, and then
okay.
That's why you are saying two lines, two indels.
Understood. Yeah.
Right?
All right. Yeah.
Okay. So now we are talking about log guard. So instead of doing a mutex was the problem. What happened with the problem was the mutex, because you can forget about unlocking it, right? So the CPP, the C++ gave us this thing, log guard, which you can use. So you don't have to specifically unlock it, right? But what is the problem with this code? Is there any problem if I give it like this?
Doesn't know where the unlock should happen?
Yes. So log guard only works. So at whatever the scope, like when that log guard goes out of scope, it gets unlocked, right? So when this particular log guard goes out of scope, only after this for loop, right? It means this particular printf is logged for one particular thread, the whole loop. Like it is same as giving the mutex.log here. Are you getting my point? What I'm saying?
Yep.
Right. So what should we do in that case? How should we put if we have to use log guard? What should we do?
No, I think we need to keep it two braces in that. Inside that, we need to give this the print save.
What if we do it like this? If we do it like this, then
this is also fine. Correct. This is correct.
Right. So what will happen now is the scope of this log guard is only inside this particular curly braces, right? So once it comes here, see it comes here, it locks. One thread will print there. Now it sees this, it goes out, and then this destructor of this particular LG will be called. And the moment destructor is called, it does the unlock. So now the second time something comes here, the other thread can also get inside this, right? It has been unlocked after this second curly braces. So this particular way of doing is RAII. Have you heard about RAII? Resource acquisition is initialization. This is a concept in CPP that you initialize something, or you take up the resource in the constructor and you delete the resource in the destructor. That is the concept of RAII. Right? Everyone is aware about it, and this is very important concept in CPP. RAII, like all the smart pointers and all are made using RAII, right? Correct? We can go ahead. Everyone gets this, why we have given this bracket?
Yes, sir.
Any confusion?
I have one doubt.
Yeah.
Yeah, as you told, like thread 1 and thread 2, if it is there and it has own stack, so every time it will start from 0, right? So
every time it will start from 0 means?
Like within the for loop,
so each
0.
thread has its own stack. So
Yeah.
each thread will start from its own 0.
Okay, each thread will, okay. So total 10 times only it will print. Okay.
Yeah. So one thread
okay,
5 times, one thread 5 times.
Okay, got it. I got confused.
Okay. Now this, so this thing is clear. Log guard, we can move ahead. When to use log guard and when not to use log guard. Is this clear?
1 second, can you say that RAI part?
Do you know the concept of RAI?
I have read it, but I forgot.
So RAI. So what happens? This is a concept. So what happens in this concept is you acquire the resource in the constructor and then delete the resource or delete or anything that you want to like remove it in the resource in the destructor.
Oh, like smart pointers.
Same as smart pointers.
Okay.
Smart pointers is made out of this RAI concept.
Okay,
So
okay.
similarly, log guard is also made out of this RAI concept. So what will happen is, see, we are creating these objects. Think of this as log guard as the class, right? So this class object I am creating and I'm passing this empty as the resource. So what could have been happening inside this class is in the constructor, it would have been doing empty.log, what we are doing earlier, right? So this code is same as doing empty.log. The moment it goes out of this scope, what will happen? This LG will get deleted. Destructor will get called.
Yeah.
And in the destructor, what could have been written inside is empty.unlock. Right?
Got it.
So after this, it has been unlocked. This lock has been unlocked.
Got it.
Correct? Got it? Okay. So this is the second way we can use it, and this is people mostly for simple users, you can mostly use this log guard so that you don't have to remember when you have to unlock. It will just goes out of the scope and it will unlock for you, right? So that you don't forget. Okay. So what else? So we have different kind of mutexes that I will finish up quickly. So what all different kind of mutexes we have? Can anyone tell me? We have different kind of mutexes for different purposes.
Shared mutex.
Okay, so one is shared mutex. Okay, what else?
Recursive mutex, like
recursive mutex. What
Time
else?
mutex.
The voice is not clear.
Time mutex.
Time mutex. Correct. Anything else? Correct. So these are broad categories of mutexes we have. So what we have been using was the simple mutex, but other kind of mutexes are like suppose recursive mutex, like this we can use. And I'll tell you when to use it. So we have something called timed mutex, like let's call it timed mutex, right? And we also have something called shared mutex. Shared mutex. I think shared mutex is in its own header file.
Yes, shared mutex.
Shared mutex. It is in separate header file, shared mutex. So shared mutex now. Yeah. So it is shared mutex. So these are different kind of mutexes we have. I'll quickly run through. So this is for simple use cases that we have seen. You do lock and unlock for the critical section. Simple use cases. And for simple use cases, you can also use log guard. Right? There is no difference if you are using it properly inside the braces, log guard and all. Recursive mutex, when can we use?
When we need to
when we want to log the same mutex again and again. So suppose we have a code where there is a recursion function, right? I'll give you a code. I'll show you how and when can we use it. Let's say I'll quickly copy paste the code. So suppose I have this function. So see this function once. Format this. Yeah. See this function. This is a recursive function. It is taking a count, and unless count is 0, this is some base condition. If you all know how does recursion work, this is a base condition. And inside this, what we are doing is we are taking a log. and then this something we are printing, and then we are calling the recursive function with one less count, right? And then we are unlocking it. So can somebody tell me if it is just a simple lock? So suppose this is some simple lock, mtx.lock. What will be the problem in this case? This is
In
very
that case,
interesting.
in that case, you are trying to acquire the same mutex lock again without releasing it.
And then what can go wrong? What will happen if we are trying to do that?
It should not allow actually without doing a lock.
We can have a deadlock. We can have a deadlock situation like.
Yeah, the answer is it will create a deadlock for you in the code. So I'll tell you how. See, so suppose the count value is 5 here. Suppose, for example, take 5. This will be neglected because count is less than count is greater than 0. The thread will take a lock, right? Now it will come here. It will call the same function for 4, right? Now it is the same thread. Now it has called for the 4. It will come here and it will try to take the same lock. But remember, it has already been logged. And it is the same thread that has logged previously. Now it will keep waiting here so that I unlock, but it is here. How will it unlock? So it becomes a clear case of deadlock that I'm just keep on waiting infinitely. Can everyone understand how this will create a deadlock? And what is deadlock? What is deadlock? Somebody can quickly tell me what is deadlock? This gets asked in the interviews also. Explain what is deadlock with code.
For example, in execution.
Sorry.
No progress in the execution. No further progress in the execution.
Your voice is not clear actually. Okay, so what is deadlock is so suppose there are two threads. A simple case I'll tell. Two threads. So and they are supposed taking two locks. I'll show you some code for the deadlock. Wait, then we'll understand.
X is waiting for a resource that Y holds, and Y is waiting for a resource
Yes.
that X holds. So
Correct. So yeah, that is very correctly said. One particular thread is waiting for a resource, and the other thread is waiting for the resource that X other thread is holding. And then they both cannot proceed with the code. So they both are waiting for each other to release the lock. And that is the situation which is called deadlock. And this gets asked in the interviews. Can explain along with the code and how will you make it proper? How will you write the code that it should not create a deadlock? Right. So let's talk about a little bit about deadlock. And then we'll see how we can remove this situation using the recursive mutex. So suppose I have this code. Just quickly look at this code. I can quickly move on to move on through these topics, right? These are just theories that we can quickly move on. But if you have some doubts, you can ask, right? Okay, so look at these two, thread 1 and thread 2. I'll just put it like this. Just only look at thread 1 and thread 2. So what thread 1 is doing, it is taking a log, some work is going on, and then it is trying to get the lock of the second mutex. So this is mutex 1 and this is mutex 2, right? So this is my code. And if you see thread 2, it is trying to get the lock of mutex 2 first, not the mutex 1, the mutex 2 first, and then it is doing some work, and then it is trying to take the lock of mutex 1. So what can happen is, suppose thread 1 comes here, it takes the lock, goes inside, and at this particular point of time, after it has taken a lock, second thread comes here and it takes the lock, this M2X2, second lock, right? And it goes inside. Now, suppose this thread comes here, trying to take the mutex 1 lock, but mutex 1 lock is taken by whom? Thread 1. So it has to wait. Similarly, at this point of time, it is trying to take the lock of mutex 2. But who has taken the mutex 2 lock? Thread 1, thread 2. So this will also keep waiting. Right. So neither thread 1 is releasing the lock and neither thread 2 is releasing the lock, and both are waiting for other locks. So the code will just not proceed after this. Both are just sitting there and trying to see when I will get the lock. Right. So this particular situation is called the deadlock. When all the threads are just waiting for other resources, and none of them can proceed with the code. So this is called deadlock. Clear, right?
Yes.
So these things that you have to show with the example also, that you can show like this. You can take two locks and then you can lock mutex 1 and mutex 2, and in the other thread you can do mutex 2 and mutex 1, and then you can tell the situation like this. Then this code can do create a deadlock situation. So to avoid the deadlock, what you can do here to avoid the deadlock, what things we can do here?
We can take a lock in the same order. Like thread 2 should take a lock L1, like mutex 1, not mutex 2 first.
Okay, so this is one thing. I can take a lock like this, mutex 1 and mutex 2 in the same order, like the same. So what will happen is it will take the lock, it will take the, so once it has taken the lock, this thread 2 will keep on waiting here. It will take the other lock, it will do its work and it will go out, so that this gets released and then this thread can take the lock. So there will be no situation where it can happen that the deadlock situation will be there, right? So if you take the lock in the same order, there will be no deadlock situation. This is one way to avoid it. Is there any other way to avoid this deadlock?
We can use try lock. So if we are not able to take a lock, we can release whatever lock we are holding.
Okay, okay. That we have not tried, but yeah. So there is also called something called mtx.try lock that we can use. Suppose there is a API that is given in log, and we can keep checking if we can take the log. If inside this, if we cannot take the log, what we'll do is we'll release the earlier log that we have taken so that other people can take the log. So this is also one way to avoid the deadlock. Yes, correct. That we'll also see in the maybe particular next class how to use try log also. Yeah, but you're correct. You can use try log also. And then there is one more API given by CPP, which is called like this, std lock directly. And how many number of locks that you have to use, you directly give inside this only. So suppose this particular thread has to do two locks, mtx1 and mtx2, you just put it inside together. So what will happen is this is an atomic statement. Atomic means this will get executed by one thread totally. So what will happen is in the thread, it will take the lock of both mtx1 and mtx2 together. It will not happen that thread 1 will take mtx lock and then thread 2 will take mtx lock like that. So this code that you can do is you can put it here instead of doing log guard like this. Right? Are you getting my point? You can use this particular API how to avoid the deadlock. So only one thread will be able to take both the locks together. Getting my point? So you will not have a deadlock. Clear? Can we move ahead?
Yes.
Right? Okay. So I'm just deleting. So deadlock thing is clear how when deadlock can occur and how you can remove the deadlocks. Right? So we were talking about this recursive function. So in this recursive function, how you can avoid is you can, instead of using simple lock, what you can use is recursive mutex. So this is something called recursive underscore mutex, right? And let's call it, maybe call RTM, recursive mutex, maybe something. And then if you use this recursive mutex inside doing lock and unlock, it will let you lock and unlock for the recursive functions. This recursive mutex knows ki, okay, this is the same thread and it is doing in recursion, so it will let you. So there will be no deadlock situation in this case. But if you use simple mutex, you will create a deadlock. So whenever there is a situation where you have a recursive function and you are creating such kind of lock inside the recursive function, take recursive mutex. That is the whole point. Don't use the simple mutex. Correct? Fine, right? The simple thing.
In recursive, then when will be the unlock will be happening then?
When it will start coming out, it will start releasing its lock.
When the stack gets means the last stack, it is how it will. Means recursive means internally multiple calls will be happening. The same function
Yeah.
is called multiple. Correct?
Yeah. So suppose this call happened for 4 and then it will try to do a lock. But at the same time, other thread is also getting created, right? So, okay, 1 second. This should be in a different function. Recursive mutex. So what I wanted to do is I'll have to do a parallel recursion, right? That's when we have to do a recursive mutex. Okay.
Amit, is it like a recursive mutex is something like a semaphore kind of thing where there is a count, something is there for the same thread again coming, so that
internally how they have done I don't know, but only thing is they might have done it through semaphore. I'm not sure internally how the implementation is, but yeah, for the recursive function you can do it like this. So suppose for this recursive function, no, you have, suppose you have like this, so you have two threads that is calling this as a starting function for this recursive function, right? So you can use this recursive mutex in this situation. So don't use, the only point is don't use normal mutex when you have a lock inside the recursive function, right? So
Amit, in this particular case where you have two threads, right? So is it like, let's say that the first thread starts with count of 5, then gets decremented and calls the same function again, then goes to count 4, and then the second thread, suppose the second thread starts now. So second thread starts when the first thread is already at 4. So the second thread will be allowed to enter, right? At that point?
Second thread will be allowed to enter because
second thread will be starting with count 5 again, right? While the first thread is at 4. Now, if the second thread completes this and then goes to the next level in the recursion tree, so it goes to 4 again. Now it will now it will try to lock, and then it will not be able to proceed. Is this understanding correct, or what?
I think it is, but can we just run it in once? Let me check it for my understanding also. This is what it should happen. Let me remove all this. But anyway, I'm wrapping up the class for today. If you have any doubts, now we can discuss that, or if somebody has to like share anything and like on the screen, and somebody was getting any doubts, so for something was not running, that we can do it now, right? So one sec. Okay. So this recursive, yeah, tell me now. You can now we can have a discussion. Now I'm not doing anything new. So okay, before we do this, the next class I'll be doing is recursive mutex. I've done. I'll quickly go through the time mutex. That will be like 2-3 minutes. We'll check, and then we'll talk about 2-3 things. We'll talk about. We have talked about deadlock. This is one thing. Second thing we'll talk about is producer consumer problem, and we'll see the code how to fix that. Third thing we'll do is reader writer problem, where we have one thread will reader inside the reader thing, multiple threads will be allowed, but on the writer only one thread will be allowed access, and that we'll do it through shared mutex. These three things is commonly asked in the interviews also, so these things we'll do in detail properly. And once this is done, say this reader writer and all this is done, after that we'll do producer consumer, we have done deadlock, we have done, and just giving you what we'll do it next week. Okay, so I wanted to do one question. I'll give you 2-3 homework questions, right? For them, depending on multi-threading part. So please try to do it and share on the Discord. Yeah, I think that's it. And we'll talk about little bit about thread pool, but I'll not do the whole coding part. The whole coding part is there on the YouTube. You can go ahead and see it. It's because I don't want to put effort and time again, that you can already go ahead and see it, because it is done properly with full code and everything. I'll share the link also, but we'll talk a little bit about it. Okay, this is done. Yeah, so mostly after that, I will close the multi-threading part after reader writer, producer consumer, and little bit thread pool that I will do. Yeah, we can take up. After that, we'll take up the async and promises and futures part. How to like return values from one thread to another. Those things we'll do. And let's see if we have time. We can also try coroutines if we can do, or otherwise we can take it up while we're doing projects. Let's see if we have time for coroutine. But till futures, promises, and all async we'll do. And after that, we'll jump into the networking part. So I think one class we'll take for multi-threading next week, and then second class probably we will start with the networking, right? And till that time, if you want to move faster, I want everyone to at least please try the whatever we have done in class and whatever the homework I'll give to you on Discord. Please try that and keep putting it on Discord if you have any confusion. Don't make the Discord silent, because I think then I feel like nobody is doing any work. Like, please do it for next 4 5 weeks, and then at least if you do it for 4 5 weeks, no, it will be like you do it for once in a lifetime, right? Once you've understand all this, you don't have to do it again and again every time. Yeah, right. So yeah, now go ahead and let's have a discussion if anyone has to ask anything. And meanwhile, I'll try to see if we can do this recursive wala thing. So I'll take this. Yeah. Or if you want to leave, we can leave also. Like, I'll not be teaching anything further for today.
I have a question where we calculated the sum for a vector. So in C++17, there's something called standard reduce, where we can give the execution policy,
Yes,
say
yes.
parallel execution or something else.
Yes,
So
yes,
how is
that
it?
will check. That will say. That will I'll teach you on that. How to use.
Okay.
There are from C++17 and some C++20 also. There are some parallel algorithms that has been given, where you put the policy as parallel, and that you can that HTL will do the thing for you parallelly what we did today. So that we'll see.
Okay.
I'll tell you about those algorithms also quickly. You are talking about whether we have an advantage or anything.
Yeah, no, I was just asking. So how is it better than this multi-threading thing which we did in the class?
You cannot say it's better and all, because internally they might be doing the same thing only what we have done manually. They somewhere they have to put the code, right, to calculate it. So they might have been doing the similar thing. I'm not saying the same thing, but they have to do the same thing. Some kind of, they'll put it into different threads, and then they will calculate, and they'll give the result if you are doing it execution policy is parallel. So I cannot directly just say ki this is better or this is better.
Okay.
Amit, one more
Right?
thing.
Yeah.
About, you told that you will discuss about the reader writer and consumer, sorry, like producer consumer, and also there is a the other thing, we make that data structure as a multi-threaded, like a threaded queue or something. Something
Yes.
about you just discussed.
Thread
I just
safe.
thought.
Thread
Yeah, yeah,
safe
yeah.
queue or thread
Queue
safe
plus
stack,
queue.
like that.
Yeah, yeah, yeah.
Yeah, yeah. I had the plan to discuss. Actually, I have kept it in my notes also. Let me see if we can, if you all guys can put in some effort and put on the Discord that you have done this much this, and then I can go a little faster also. Right? So somebody who is very beginner on, like someone said yesterday that she is very beginner, I think. Is she present here? So
Yeah,
somebody who is, yeah, hello.
yeah. This week I'll do the homework.
Yeah, so Sriyanka, you were yesterday, like you were doing the multi-threading for the first time, right?
Yeah.
So yeah, so Sriyanka, okay, so I'll expect that you are telling me next week that you are like quite versed with multi-threading coding, right?
Yes.
So if you all go little faster, everyone, then I can go a little faster. Like I will not spend too much time on like putting an effort on producer consumer. I can directly write code and I'll show you, okay, this is happening, right? So it depends on you. If you guys put a little more effort from your side, write code, put it on Discord, I can go a little faster.
Yes, I'll do that.
Yeah. Okay.
Yeah, and Amit, actually, I watched about that like thread pool you have told. It is very nice actually. Thanks.
Yeah, that I've done it
All
properly.
this.
That's what I'm saying. That's why I'm saying I will not do it properly here on class also. Because it will again take the same time. I'll do the same thing again. You can directly in this week only, you can go ahead and check it properly. You can,
Yeah,
this is I
or
think around
then
1 hour video.
yeah, run or then probably if you have any doubt in that anything, we can even ask also.
Correct,
That we
correct. You
can
have
try.
doubt, then we can discuss. That is not a problem. But I don't want to take one class for thread, because it will take a one class if I do it properly. because a lot of template discussions and all are also there. How to make it more generalized, right?
Yeah, it is too much advanced. C++11. Yeah, the template I saw that. Very good.
Yeah, so please watch that video. That is very like properly done video. I'll give you the link and the code also. What that thread pool in what the whole code is there, no, in the thread pool video I've done. I'll give you the code also in the notes, so you can go through the code. You can write it properly yourself, and if you have that, so you ask on Discord. But then we can save the time. We'll not be discussing too much about thread pool because you already know. Right? Because I don't think I have anything else to discuss other than what was already told in that video. Right? So please look at that video for the thread pool. And that is very important.
Yeah, Amit, actually that and something I also wrote about the chat box related. Those are the two reasons I joined this class. Thanks.
Nice, thank you.
Amit, like you spoke about this mutex and logguard, right? So
yeah,
I understand. So they are the ways that you can implement a critical section. But why would so? For example, when you
not
have
implement,
two threads,
synchronize your critical section.
Synchronize your critical section. Okay.
Yeah. Hmm.
Like for example, let's say that you have 2 threads or 3 threads, right? And then you are, let's say that all the 3 threads have the same. You're creating those threads by passing in the same start function.
Okay.
So like they are going to have their own copies of, so each thread is going to have its own stack, and then they will have their own copies of the local variable. So then why is there, how does a critical section arise? I mean, what is the what sort of problems
critical
do you
section
face?
arise because they are trying to access the same variable, or maybe they are writing to or changing the same shared variable. If you see all the discussions we had, no, for the critical section, I was trying to do the same thing, same shared thing that we are trying to change. So earlier when we were doing the print thing, what was the shared thing that everyone was changing? Can you guess? What was the what was the shared thing among all the threads?
Yesterday out.
Correct. It was the console. We are printing to the console. So
Okay.
So the
output
shared
buffer.
So yes, correct. The output buffer was the shared thing. So you were seeing the jumbled output, right? Sometimes the thread 1 is doing first, sometimes thread 2 is doing first. So I was trying to synchronize the output among all the threads. So suppose if I have some function like this, let's see. See here. It is only the problem only arises when they are trying to change the shared thing, not the local things. If you are changing that is separate for each thread, that will not create a problem. See this code. So this is some global variable I have put here, int counter equal to 0, and inside this function I'm trying to change this variable, this particular global variable, right? And if I try to have this code, I'm trying to have two functions with this starting function as this increment. Suppose I have these two things. Thread 1 is also trying to start with increment, and this two is also trying to start with the increment, right? So what will happen is, suppose this is not here. So both are trying to increase the counter, which is the shared among both. This is not the stack. This is not on the stack counter. Remember,
Agreed.
this is global memory. So then this becomes your critical section, because you never know why. So this plus counter, if you see, it is like this: counter equal to counter plus 1 internally, right?
Yeah.
So what can happen is one thread can come, it will see the value of counter and then increase the value from the previous value, right? But it can happen that one thread, while it has seen, it has been preempted by other thread before even it has increased.
Yeah.
Getting the point? So the problem only arises when you have a shared memory. When two threads are trying to access the shared memory.
Yeah.
Not the local one, the stack one.
Yeah. Thanks, Amit. Yeah. Got it.
Yeah. Yeah. Recursion one, I think I've done. Okay, we'll see it afterwards. So anything that can we wrap up for today? I think, or anyone has to show anything. Anyone want to share anything?
I have one question.
Yeah.
So can you go to the where you were doing the multi-threading part, that code? So the start and end which you are calculating, I didn't understand that part.
Acha, so we are calculating the chunks, right? So
Yes. So when data is coming, so we are dividing by the threads, we are getting one chunk. Now why you are doing that I into that, I didn't get that part.
That is simple mathematical calculation. That
But
doesn't have. I'll show you.
I think I got diverted somewhere. So
You are using Instagram on one hand.
no. Like so many questions are there now, so I was
Don't
focusing
worry.
one thing and something. Yeah.
One sec. I'll paste the code again. These all codes I'll give you as notes also, that you can see it later also. Acha, we're having here only, right? So here the confusion is where
The start I into chunks, like chunk size we are getting fine. Like I into then and then next one also end also I didn't.
See, what we were trying to achieve in that this particular code. So we have a lot of data. So what we were doing is we are dividing the whole data into some chunks, and we are telling, hey, one thread, you go and calculate the sum for this chunk. One thread, you go and calculate the sum for this chunk, right? So we have to create that chunk to give it to one particular thread. So how we are giving? So see, this particular thread that we are creating, we are telling for this particular data, you only calculate for this from start till end. We have to give this particular chunk right here. So that's where they can do a accumulator from start till end. And how we are calculating is, suppose you have 100 data, suppose, right? And you have suppose created 4 threads, suppose.
4 threads, yeah.
Right. So how many each chunk should be?
25.
25. So how will we calculate? So what will be the start of this?
0 to 25.
0 to 24 should be there.
0 to 24, sorry.
Correct. Right. So what will be the start? So see, when the first time for loop comes, the value is 0. And chunk size is what? We have calculated this chunk size here. So which is 25. So what the first time the start size is 0, and what will be the end size? So right now this will not be executed because right now it is not the end of the I. So it will come here and it will do I plus 1 into chunk size.
Oh, got it. So the
it will
last,
be
yes.
yeah.
So the last part you are calculating. No, now I got it. Like I 0 into 25, that is the next I is equal to 1, then it will start from 25. Yeah. And the last which you are calculating now, so you are saying this much data is left and then end that one.
You have confusion there.
End part, like the first 25, then 50, then 75 it is calculated, and then remaining some data were there, now you are calculating that part.
So for that part, if at the end you have whatever it is left, for that, so for 25, for 100 by 4, it is becoming naturally by 25. But suppose if it is in decimals, suppose you have 120 data and by 4 you are doing. Right. So at the end, if you just go and see the mathematics, you do it that dry run once for simple data. You will understand this, right?
Got it.
Okay. So goodbye for today. Any more question?
Amit, can we discuss exception handling as well in the next class while implementing
exception handling in the sense? In general exception or any particular exception?
During implementing the mutexes, right? If any exception occurred, then how it will come up from that block. So those kind of scenarios.
Okay, let me see. Okay, I'll keep this in mind.
Thank you.
Okay, what else?
I was getting there.
Sorry, one at a time.
Sorry, this code will be shared right now.
I'll share the code, yes.
Sure.
I'll share all the notes, whatever has been taught, and I've written extra things also that you can go through. So both the things I'll share.
Thank you.
Yeah, I was getting there at that build system. Could you please help?
Share the screen. I'll stop my share.
Okay. The screen is... Yeah. Are you able to see?
I am able to see, yes. Yeah. So what is the problem?
So like I am able to run.
Okay.
But during build, I am not like the debug folder is not creating. It's like
Run the cmake dot once.
cmake
Let me see.
okay.
Okay, you are using the same thing, no? You are not nmake problem was coming.
Yeah.
So that is gone, right?
Yeah, now cmake dot is also working, I think.
Okay,
Yeah.
so now run cmake dot dash build dot.
Cmake dash
build dot.
So it's like checking build system, but not
1
creating
second.
.exe.
It should create cmake files, project solution. Where are we? Which folder can you do? pwd. Okay, h advanced cpp classes.
Inside build.
Advanced cpp classes. Okay, and then build. Okay, and you have a cmake list here. Go to cmake list.
This is outside.
Is there anything inside also?
Also, I think that your CMake list should be saved. It says that white dot. Maybe you forgot to save it.
Okay, I'm saving it.
Okay. Yeah, now
Okay.
I think now it came. It came.
Okay. Just for the automatic save doesn't happen.
I think it is not enabled. It can be enabled automatic save.
Okay, I will check. Okay, after debug, I think
some error is there that you can check. Some error
yeah,
is
I
coming.
will check. So I think debug folder is successfully created, right? Correctly.
Yes.
Okay. So yeah, I think I will be able to.
Some linker error.
Yeah, I will check that.
Okay, fine.
Okay, thank you.
Okay. So let's wrap it up. It's already been 4:30. So let's come back next week and do a lot of multi-threading and start with the networking also. So okay, everyone, goodbye. Have a great week.
Okay. Where do you post the homework thing? Discord?
On
or?
Discord.
Okay, thank you.
Thanks, everyone. Have a good week.
Bye. Bye-bye.